In problem number 2, we have the number of gallons, P of t, of a pollutant in a lake changing at the rate of P prime of t is equal to 1 minus 3 e to the negative 0.2 squared of t gallons per day, where t is measured in days. There are 50 gallons of the pollutant in the lake at time t equals 0. The lake is considered to be safe when it contains 40 gallons or less of a pollutant. Question A, is the amount of pollutant increasing at time t equals 9? Why or why not? So for this I'm going to enter the equation or the derivative that I'm given into y1. I can set my window from negative 10 to positive 10 or zoom standard. Either way would accomplish the same thing. And then I'm basically just looking for the value of this derivative function when t is 9. So I do second calc, and I'm not going to go to derivative because this is the derivative. I just want the value of this derivative when t is equal to 9, and the value of the derivative, which you can see is negative 6.646. At this point I'm ready to answer the question. P of t is increasing when P prime of t is greater than 0. Since P prime of 9 is equal to negative 6.646, I say that P of t is decreasing there and not increasing. So that's the answer for part A. Part B, for what value of t will the number of gallons of pollutant be at its minimum? And this is going to be an absolute minimum. It's the lowest value. But here we're not working with a closed interval. So for that reason, we're just looking for where P prime of t changes from negative to positive. So P of t will be at its minimum when P prime of t changes from negative to positive. We go back out to our graph and we can't see where it changes from negative to positive. So I'm going to increase the y-axis from 0. I'm going to go out to 100. And I can narrow the x-axis from 0 to 100. I'm going to narrow the y-axis from negative 5 to positive 5. So the x-axis changes from 0 to 100 by 10. The y-axis changes from negative 5 to positive 5 by 1. And I go out to graph. At this point I can see where the graph crosses from negative to positive. And I go out to find that using a 0 function. Second calc option 2 for 0. The left bound, say 0. The right bound, 100. Since there's only one place where it crosses, guess somewhere in between there. And I have 30.174. And so I say this occurs at t equals 30.174, where the derivative changes from negative to positive. Now we should still be cautious and not assume that the graph will not cross back over the x-axis and become negative and then once again cross over from negative to positive. So I really should double check and go out to my x values and go from x min is 0 to even as much as 500 by 100 is fine there, just to see what happens. And so we've gone from 0 to 500. It's pretty clear that it's not going to cross back over the x-axis, and so we have the only value where there is a minimum. The next question asks, is the lake safe at that point? Well, we start off with 50 gallons, and recall that the definite integral from 0 to 30.174 of P prime of t dt gives us the change in gallons of pollutant in the lake over that period of time. So if we take that change and add or subtract it to 50, that will give us our eventual value at time t equals 30.174. To find that, I'm going to take the definite integral, option 7, lower limit 0, upper limit 30.174. It gives me a net change of negative 14.896. From our calculator, again, we can just add that to 50, and we get 35.104, so it is safe at that point. We'll continue in the next video.